Next question. Find the rank of matrix A is equals to 0, 1, minus 3, minus 1 first row, 1, 0, 1, 1 second row, 3, 1, 0, 2 third row, 1, 1, minus 2, 0 fourth row. So first note on that given matrix. Next we need to reduce this matrix into echelon form. The point number 1 is the leading entry of non-zero row must be 0, but here leading entry is already 0. That's why what we are going to do is in the first step we are going to interchange row number 1 and row number 2. Therefore right here R1 interchanges to R2. Therefore the given matrix transformation goes to, first we are going to write 1, 0, 1, 1. Next we are going to write 0, 1, minus 3, minus 1. Third row as it is 3, 1, 0, 2. Fourth row as it is 1, 1, minus 2, 0. So next, already second row first element is 0. Now we need to make third row first element 0, fourth row first element 0. So for that again we are going to apply the row transformation. Therefore A transformation. So right here we are not changing first row as well as second row, so keep it as it is 1, 0, 1, 1, 0, 1, minus 3, minus 1. Correct. Now R3 we are changing, therefore write R3 changes to R3 minus 3 times of R1. So that time this element goes to 0. Similarly, R4 changes to R4 minus of R1. That time this element directly goes to 0. Now apply R3. So you can see here R3 is 3 minus 3 times of R1 is 1. Complete the bracket, it is 0. So right here 0. Next R3 is 1. 1 minus 3 times of R1 is 0. So it is 1. So right here 1. So next R3 is 0. 0 minus 3 times of R1 is 1. Is minus 3. And next R3 is 2. So 2 minus 3 times of R1 is 1. So minus 1. Next apply the next one, R4 minus R1. 1 minus 1, 0. 1 minus 0, 1. Minus 2 minus 1, minus 3. 0 minus 1, minus 1. Correct. So next, now A transformation. Now first row we are not changing, keep it as it is 1, 0, 1, 1. Second row also we are not changing, so keep it as it is 0, 1, minus 3, minus 1. Next these two elements we have to make it 0. So for that R3 we need to change as well as R4 we need to change. Therefore apply the row transformation. R3 changes to R3 minus R2 and R4 changes to R4 minus R2. So apply R3. 0 minus 0 is 0. Next R3. 1 minus 1 is 0. Next R3. Minus 3 minus of minus 3. Okay, you can see minus 3 minus of minus 3, 0. So right here 0. Next minus 1 minus of minus 1. minus 1 minus of minus 1, again 0. Next R4 minus R2, 0 minus 0, 0. 1 minus 1, 0. R minus 3 minus of minus 3, same, minus 3 minus of minus 3, again it goes to 0. Similarly minus 1 minus of minus 1, again 0. Minus 1 minus of minus 1, again 0, again 0. So if now after applying row transformation for third row as well as fourth row, we are getting the 0. Therefore in this example, rank of a matrix directly goes to 2, or we can write row of A is equals to 2, because if you want to see the rank of matrix, we need to search number of non-zero rows. This is the first non-zero row, this is the second non-zero row. Therefore rank of this matrix directly goes to 2. Next question, find rank of matrix A is equals to. First we need to reduce this given matrix into echelon form. For that, first leading entry should be 1, but if you observe this matrix here, the leading entry is not 1. Therefore first we are going to apply the row transformation. Therefore A transformation. So which row transformation we are going to apply here? First R2 changes to R2 minus R1, R3 changes to R3 minus R1, R4 changes to R4 minus R1, R5 changes to R5 minus R1. First column, first row we are not changing, so keep it as it is. 91, 92, 93, 94, 95. Second we are changing R2 minus R1. 92 minus 91 is 1. 93 minus 92 is 1. 94 minus 93 is 1. 95 minus 94 is also 1. 96 minus 95 is also 1. Next R3 changes to R3 minus R1. 93 minus 91 is 2. 94 minus 92 is 2. 95 minus 93 is 2. 96 minus 94 is 2. 97 minus 95 is also 2. R4 changes to R4 minus R1. 94 minus 91 is 3. 95 minus 92 is also 3. 96 minus 93, 3. 97 minus 94, 3. 98 minus 95 is also 3. And last, R5 changes to R5 minus R1. 95 minus 91 is 4. 96 minus 92 is 4. 97 minus 93 is 4. 98 minus 94 is 4, and 99 minus 95 is also 4. After applying the row transformation for second, third, fourth as well as fifth, we are getting here 1. So according to the echelon form, the first leading entry should be 1. That's why in the next step what we are going to do is we are going to interchange R1 as well as R2. Therefore write R1 interchanges to R2. Therefore first write R2 value 1 1 1 1 1. Next 91 92 93 94 95. Next R3 R4 R5 keep it as it is. 2 2, 2, 2, 2, 3, 3, 3, 3, 3, and 4, 4, 4, 4, 4. Okay, this is the transformation. Now leading entry is 1. Next we need to make these column elements 0. Correct. Therefore a transformation to first row we are not changing, so keep it as it is. Next apply row transformation. R2 changes to R2 minus 91 times of R1. Okay. Next R3 changes to R3 minus here 2, so 2 times of R1. Next R4 changes to R4 minus 3 times of R1. Next R5 changes to R5 minus 4 times of R1. So apply. Sorry. R4 changes to R4 minus 3 times of R1. R5 changes to R5 minus 4 times of R1. So now apply. First R2 minus, R2 is 91. 91 minus 91 times of R1. R1 is 1. Therefore directly it is 0. Next 92 minus 91 times of 1. 92 minus 91 times of 1 is 1. Next 93. 93 minus 91 times of again 1. 2. Next 94 minus 91 times of 1. 3. And last 95 minus 91 times of R1. R1 is 1. So this is 4. Next R3. R3 minus 2 times of R1. 2 minus 2 times of 1. 2 minus 2 is 0. Again 2 minus 2 times of 1. Again 2 minus 2 is 0. Here also same 0. 2 minus again 2 is 0. 2 minus again 2 is 0. Okay, you can see 2, that is R3 minus 2 times of R1 is 1. R1 is 1, so directly it goes to 0. Therefore all these values directly goes to 0. Similarly R4. R4 is 3 minus 3 times of R1. 3 times of R1 is 1. 1. Therefore again this value directly goes to 0. So right here 0, 0, 0, 0, 0. Next R5 changes to R5 minus 4 times of R1. R5 is 4 minus 4 times of R1 is 1. So again 0, 0, 0, 0, 0, 0. Therefore finally here we are getting 3 0 rows. Therefore we need to search number of non-zero rows. How many non-zero rows are available here? There are 2 non-zero rows. Therefore rank of this matrix is 2, or row of A directly goes to how much? 2.